Physics.
Hi kids, I'm your teacher Mr. P. Today I'm here to teach you all about momentum. Does anybody here have any idea what momentum is?
Mr. B, I know. It's energy that an object gains through motion.
Isn't that kinetic energy or something?
While I appreciate your enthusiasm, Caitlin, Sahil is actually correct. What you described is kinetic energy. Rather, momentum is the ability of an object to stay in motion. The more momentum an object has, the harder it is to stop that object. Momentum is mass times velocity. Because velocity is a vector, momentum is also a vector. Brendan, can you please determine the units for momentum? Mass is measured in kilograms and velocity is measured in meters per second. So momentum must be in kilograms times meters per second. Very good, Brendan. You're so smart. Thanks. Okay.
Mr. B, I know that mechanical energy is conserved when there are no external forces. Is that the same for momentum?
That's correct, Caitlin. In an algebra-based physics class like this one, we assume momentum to be conserved for all collisions. There are three types of collisions.
Hey, Mr. B, mind if I interject?
Sure, Mr. Fullerton. Go right ahead.
Who is that?
Why, that is the Dan Fullerton from aplusphysics.com.
Thank you, Caitlin. There are three types of collisions. The first is an elastic collision, where you have the same amount of objects before and after the collision. Kinetic energy is conserved. The second is an inelastic collision, where the colliding objects stick together. Kinetic energy decreases. The last type is an explosion, where you start with one object and end with two. Kinetic energy increases.
Thank you, Mr. Fullerton. Appreciate your help.
No problem, Mr. B. Thank you. Mr. Morgan clearly taught you well. Goodbye, folks, and make it a great day.
Bye,
Mr.
Mr. Fullerton. Sahil, please read the problem, and Brendan, please translate.
A 12-kilogram toy train car moving at 3 meters per second on a straight level train track.
Stop. M1 equals 12 kilograms, and V1 naught equals 3 meters per second.
Collides head-on with the second train car whose mass is 36 kilograms and was at rest on the track.
Stop. M2 equals 36 kilograms, and V2 naught equals 0 meters per second.
If the collision is perfectly elastic and all motion is frictionless, calculate the velocities of the two cars after the collision.
V1 final and V2 final equal question mark. Okay, now Caitlin, do the problem.
The initial momentum equals the final momentum. So, M1 V1 initial plus M2 V2 initial equals M1 V1 final plus M2 V2 final. This is a perfectly elastic collision. So, plugging in numbers, 36 equals 12 V1 final plus 36 V2 final. Only kinetic energy is present. So, 1/2 M1 V1 initial squared plus 1/2 M2 V2 initial squared equals 1/2 M1 V1 final squared plus 1/2 M2 V2 final squared. Plugging in numbers again, we're going to have 54 equals 6 V1 final squared plus 18 V2 final squared. And we're solving for V1 final and V2 final. Both equal 1.5 meters per second, and V1 final equals negative, and V2 final equals positive velocities.
Everyone brought one up. Kids, stop fooling around, please. And very good, Caitlin. Our results make physical sense because this is an elastic collision. The total mechanical energy at the beginning equals the total mechanical energy at the end, and there is only kinetic energy throughout the problem. The velocities of the cars must be opposite because after the collision occurs, the trains will be moving in opposite directions. On to the next problem. Brendan, please read the problem, and Caitlin, please translate. Two toy trains are speeding directly towards each other. One is a 4-kilogram train moving with a velocity of 6 meters per second to the right.
Stop! M1 equals 4. V1 initial equals 6.
The other train has a mass of 2 kilograms and a speed of 4 meters per second to the left.
Stop! M2 equals 2. V2 initial equals -4.
If the trains connect together after the collision, what is the resulting velocity?
V final equals question mark.
Stop it. Please solve the problem.
Since there are no external forces acting on the system, the initial momentum is equal to the final momentum. So M1 V1 initial plus M2 V2 initial equals V final times the quantity M1 plus M2. Plugging in numbers, that's 4 times 6 plus 2 times -4 equals V final times 6. So V final equals 24 minus 8 divided by 6, making V final 16 over 6, or 2.67 meters per second, with 3 significant figures.
Caitlin, please read the problem and Saho, please translate.
Sure, Mr. B. Jim and Dwight are standing on a longboard and moving to the right at 2 meters per second.
Stop. V initial is 2.
Dwight is 100 kilograms.
Stop. Mass of Dwight is 100.
Jim jumps off the longboard to the left at a speed of 1 meter.
Stop. Velocity of Jim final is 1. Positive 1. Oh, wait. Velocity of Jim final is -1 because Jim jumps off to the left.
Good catch. It's very important to remember your signs. Caitlin, please continue reading the problem.
Okay. After Jim jumps off, Dwight is now moving to the right at 3 meters per second. Determine the mass of Jim.
Velocity of Dwight final is +3, and the mass of Jim is question mark.
Hey, Jim looks like me, and Dwight looks like Sahil.
I like Jim's shoulders.
Bro, sucking in the shoulders. It's not cool.
Guys, please focus. Brendan, please solve the problem.
The final momentum equals the initial momentum. So the mass of Jim plus the mass of Dwight times the velocity of Jim and Dwight equals the mass of Jim times the final velocity of Jim plus the mass of Dwight times the final velocity of Dwight. Plugging in numbers, we get 2 times the mass of Jim plus 200 equals the negative mass of Jim plus 300. Solving for the mass of Jim, we get the mass of Jim equals 100 over 3, or 33.3 kilograms with 3 significant figures.
Good morning. I want everyone in Mr. Morgan's 3rd period physics class to know something important about momentum. Class, what is that something?
You can't run from momentum. Yeah, I tried once. That did not go well. You guys remember?
Remember the tree?
And the cow. Oh, that was good.
It was really good. Oh, I can't believe you tried.
Yeah, you told me about that. It was pretty unfortunate.
Okay, that covers it. A special thanks to Dan Fullerton from aplusphysics.com and to Mr. P from flippinphysics.com. Thank you very much for learning with me today, and I enjoyed learning with you.
No, hold up. That's my line. You can't say that.
No. That's my line.
What are you going to say next? The physics works? Come on.